exploring the intersection of resilient technology, organizations, and people. REdeploy.
Bob Ross once said, we don't make mistakes, we have happy accidents. So I'm going to tell you a story about a happy accident that made us into chaos engineers. So I'm Paul. I'm on the cloud team at Stripe. We build tools so the rest of Stripe can run on the cloud providers, AWS, without having to think too much about it. So here's what I'm going to cover. First, I'll start with the motivation for this project, which was our instance age. I'll go over what that means to us and why old instances are bad for security. Next, I'll talk about the design of the project, which was lifespan management. Then the name of the project was called Lifespan Management. Then I'll go over 5 chaotic discoveries that this project exposed for us. And then finally, I'll wrap up with summary and some closing thoughts. OK, so first, let's talk about instance age and why we decided to care about it. So some terminology, and instance in this case, we're just talking about a cloud-hosted VM, just like an EC2 instance. And age, I mean the time since launch. So in picture form, if we have like a histogram here to illustrate, the x-axis is age, and the y-axis is like the number of hosts that are that old. In this case, we've just launched an instance. A couple weeks later, it gets a little older, it moves to the right. Months later, it's much older. And we eventually terminate and replace that instance. So the old instance goes away, and we've replaced it with a new, younger one. So here's an artistic rendering of what our instance age histogram looked like at the start of this project. Replacement was mostly ad hoc, so we had this lumpy distribution. We could even recognize some landmarks among the kind of peaks. So we launched a new Hadoop cluster, and that one had hung around, and nobody had replaced anything on there. We had some big migration that touched all the hosts except for a couple, and nobody had touched. People had replaced a lot of things since then, but maybe not a couple. And then we had those horrifying hosts that have been around for forever and nobody really wants to touch, but they're still there. So what's wrong with having these old instances? So we can think of replacing an instance as like a fire extinguisher. When an instance metaphorically catches on fire, it starts misbehaving in some way, one of the things we can do is replace it to try to fix that problem. So sort of extinguish the fire. However, if we have not launched it recently, if it's a last replacement was a long time ago, some breaking changes may have landed since that replacement happened. In that case, our fire extinguisher has kind of caught fire on itself. And instead of solving the problem, we've created an entirely new problem. And our younger instance would be less likely to cause that problem since we'd replaced it more recently. Another problem with old instances was the accumulated changes that happened over time. So when you replace an instance, you take one code path, and then when you're changing in place, you take this other code path. So in this case, we have the freshly booted chicken, and then this thing that's accumulated a bunch of change that ends up looking more like a duck in the end. And will replacing a duck with a chicken work is a question. I don't know. But it's hard to know ahead of time when you do this replacement. So final 2 problems with instances were security related, and that was a big motivator for us. One issue is a little bit more hypothetical. So if a host was to get compromised, it's nice if that host didn't live very long, if it was then replaced versus sticking around for like years. And the other issue is a little bit more practical. So this involves like security patches. Imagine that a critical vulnerability has been announced, the patch has been released, and let's say it was released like 10 days ago. So any instance that was launched shorter than 10 days ago, we feel pretty comfortable with our process that host has had the patches applied. These launches more than 10 days old require more work. I'm sure we have a process to update them, but for things like kernel upgrades, we might need to schedule a reboot. We have to have some sort of interruption in service. And it's just a lot more work to actually ensure that patch gets applied to those places. And if we're relying on those sort of automatic upgrades, we have to make sure that those are actually happening. You kind of get the idea. So what we'd like to do is sort of just jam all of these instances over into like the green happy zone. And with that goal in mind, we set out to get more things into that green zone. Enter lifespan management. So this was our project where we wanted to set a maximum lifespan on instances, and once they exceeded that lifespan, we would just replace them automatically without having a person involved. So there were 3 components to this project that I'll explain, and I'll explain them in future slides, but I just want to give you the terms. So there's an auto-scaling group, or an ASG, Terminator, which is our graceful shutdown system, and then the lifespan manager itself, which was basically just a stateless cron job. So what is an auto-scaling group? So it's an AWS primitive, lets you specify a target number of hosts, and then AWS will maintain that number. So if, in this case, 2 hosts are terminated on the left, AWS will launch 2 new hosts to keep you at that steady state. Now let's talk about the Terminator. This slide is a little bit noisy, so I'll go through the steps. So it's our graceful termination system that lets you delay termination and do some cleanup before actually shutting down. So in step 1, we make a terminate API call to AWS. Step 2, that AWS calls out to a Terminator process running on each of our hosts. And it does some cleanup. So it's like shaving whatever yaks it needs to do before actually shutting down. And meanwhile, while it's doing that, it's sending heartbeats to AWS to say, hold up, don't turn me off. And then it finally gives a thumbs up in step 3 to say, OK, I'm good to shut down. And then 4, AWS actually shuts down the host. The last piece of the puzzle is the lifespan manager. So this is the cron job. It runs periodically and checks if it needs to terminate machines, checks the health of the auto-scaling group and the age of instances. It terminates one, and then we let the ASG bring up the replacement. It waits until that replacement is healthy, and then checks again to see if it needs to terminate any new hosts. We had a design decision to make about how to do this replacement, and it was sort of this, we could either terminate first or we could launch first. So if we terminated first, we would terminate a host, let the auto-scaling group replace the host, and we'd decrease our steady state for temporarily. And if we launched first, we would have to increase the size, wait for the new host to come back up, and then eventually follow up and decrease the size back down. So we ended up deciding on terminate first because it required us to handle less state, and we figured our infrastructure should already be resilient to losing a host at a time because AWS maintenance events happens, failures happen, and we haven't had any huge problems with that, so we should be able to handle that. This is where things start to look a little bit more like a chaos monkey situation, where we're positing that we are resilient to this problem and then going for and actually checking. And this is where it turned out to be a little bit more chaotic than we expected. So we figured we were fine, right? We had health checking, we were doing graceful termination, and then terminations already happen. So this isn't anything new we're introducing to the system. So this isn't really a chaos system, right? We're being very gentle about terminating these instances. It should be totally fine. So we had this system, we had this design, we tested it out in QA, and we said, now what? How do we get this out to the rest of the company? We started out with a rollout plan of breaking it up into labels. So we had 3 labels, basically. We had stateless, which meant it was safe to replace. We just had to wait for it to finish whatever request it was doing, and we could shut it off with no problem. Stateful automated was replaceable, but it had some graceful shutdown to hand state off. And then requires operator were those ones where we really wanted a human to be watching this and didn't want it to just have our automation kind of wreak havoc on it. So it ended up being a year-long journey to get this rolled out. So this chart shows our adoption over time. The blue hosts are the ones that had lifespan management enabled. The red hosts were the ones that were stateless, so we deemed that those were eligible. And then the yellow ones were the stateful ones. And so we didn't plan to tackle the stateful ones as part of this. And we didn't expect it to take this long, and I'll go into why it did next. So it's automated termination, right? What could possibly go wrong? This is totally fine. Things got a little chaotic. Turns out health checking is hard to get right. Termination is hard to do gracefully. And we increased the number of terminations we were doing by about 10 times. So things that used to just fail once, and then you would retry and say, oh, this is a termination wouldn't be happening. You couldn't do anymore because terminations were always happening. So now I'll get into the 5 chaotic discoveries that the lifespan manager was nice enough to teach us. First thing we learned, or it taught us really, was how not to health check. So we had someone coming into our channel with the lifespan manager terminated all the LDAP servers. We're locked out of QA. This is not a good way to start the morning. So on the right, we had things that looked like LDAP servers. They were called LDAP servers. They had launched normally. But an error in our deploy tool had caused them to not actually be running LDAP. So to all of they looked very much like LDAP servers, except for the LDAP part. But we thought, we have health checks. How did this happen? There's no way that this, these chickens on the left should have turned into these ghost machines on the right. What happened here? And so we dug into how our health checking was happening. And here's our lifespan manager on the left asking this auto-scaling group where one of the hosts is not actually running LDAP. And the 3 healthy hosts are reporting, yes, I'm running the LDAP service and it's passing health checks, and then I'm not in maintenance mode. So I'm healthy there too. And then our unhealthy one is saying, definitely not in maintenance mode. I'm good to go. And our lifespan manager said, everything's green. I see all green health checks. This is great. I'll keep terminating. So 3 terminations later, we have no LDAP servers, and we were locked out of QA. So what we learned there was that just because something had no unhealthy checks doesn't mean that it's actually healthy. We instead needed to define explicitly what it meant to be healthy beforehand and have the lifespan manager have that knowledge ahead of time. So this led to more config that the lifespan manager had to manage, but it ended up being a net positive for us. So we already had the capability to specify a list of health checks. We had foreseen that this might be something that we wanted, but the default list was just that maintenance mode check, which was, as we saw, not very useful. And we didn't have a strong recommendation that we were giving to people to say, you should really populate this. So we made all of our tools complain very loudly if you didn't have a health check list in place. And so here's what it looked like after we added that expectation. So our lifespan manager asks again, and again it says, OK, now there's no LDAP running. I better wait, and I'm not going to lock you out of QA this time. So our next story is about our Kubernetes workers. You might be able to guess what happened here. So somebody came in again and said, our Kubernetes workers are going down hard. But let's go back to our Terminator. We have this graceful shutdown system. How are they going down? We should be really graceful here, right? What we observed was that in the case of the Kubernetes workers, the Terminate was ignoring all of our graceful pieces. And it looked like it was running, so we invoked the Terminator, we started sending heartbeats, and to all appearances, it looked like AWS was just ignoring them and shutting down the instance. And we dug more into it, we were really confused by this, until we realized that there are 2 very similar Terminate API calls, and it turns out we were using different ones. We assumed that they did essentially the same thing, but they don't. We were using one for our laptops, and that's how we were verifying that the Kubernetes workers were safe to onboard. Was we tried replacing one, it went through all the motions, and we thought, this is great. So it invoked the Terminator, sent the heartbeats, waited for the thumbs up, and then shut down. The lifespan manager was using the other API call, which behaved more like a hammer. And this was still confusing to us because we had other workflows running on the system that didn't have this same behavior. And it turned out that the other workflows just had terminators that either ran really fast or didn't run at all. They didn't really care if their terminator ran. So this taught us to be more mindful of the new workloads that were being onboarded. So we didn't realize that the Kubernetes workers were fundamentally different than the other workloads we had, that they had this really sensitive termination requirement. And it also taught us to make the chaos really easy to turn off. So fortunately, the person who found that the Kubernetes workers was dying really quickly was able to find our runbook and turn it off before it turned into a really big deal. So that was another lesson we learned there. So the next discovery, I'm calling the Blackhole Scenario. And again, so I promise this is the last time you have to see this slide. So again, we had this Terminator, and I really want to focus on the step 3 here, the heartbeats. So there's really only 2 options for the heartbeats. You could say delay termination, or you could proceed with termination. There was no cancel. So once you sent that terminate API call, that host sort of entered the black hole. There was no escape. It was going to be shut down, which was not great for if our customer provided exit script exits non-zero or it times out, or if we hit rate limits on AWS and couldn't send the heartbeats. This instance was going down, and there was nothing we could really do about it. And then the replacement would come up fine, so the lifetime manager would continue and happily, cycle through the whole ASG and say, this is all great, and say the terminations will continue until morale improves. It would have no problem just keeping, cycle through the whole ASG, and maybe none of them would actually successfully exit. So we hit this fork in the road. So the black hole behavior was more similar to an actual hardware failure. In a hardware failure, you can't abort. You can't cancel a hardware failure. We could continue with that hard line and tell our customers, you should be resilient to a hardware failure, and this is something that you should deal with and make your thing either resilient to a non-zero exit or make this thing not exit in an error. But then we went back to what our original goal was, which was to reduce instance age and to reduce developer toil. Our original goal was not to simulate hardware failure. And our goals really required widespread adoption of this tool. We couldn't, if we wanted to reduce the global instance age, we can't just have some people say, this project is not for me. So we ended up adapting our system to be more forgiving and less like a black hole. So we called Touch Termination. So before we kicked off the terminate process with AWS, we would talk to the terminator from the lifespan manager first. So it would kick off the termination, start shaving the acts, and then until it got the thumbs up from the terminator, it wouldn't actually do the termination. So that way, if something went wrong, we could file a ticket or really pause termination and not just kind of blow through the whole fleet. What we learned here was to align incentives. It would be pretty valuable to be fully resilient to hardware failures in our system, but our primary goal needed us to increase adoption. And our customers had less incentive to adopt if the platform was very unforgiving. It also demonstrated that while most systems didn't care about graceful shutdown, other systems cared a lot, and they needed to have that option for the terminator to exit non-zero and for someone to manually intervene. The next story is about self-service gone wrong. So I'll go back to our adoption graph here, and you might notice the beginning of the year, let's see, yeah, right around here, there's a pretty steep uptick in our adoption. And I'll zoom in there, and you might also remember around that time of year, Spectre Meltdown came out. And so this was when the vulnerabilities and patches were released, and my team was also in charge of getting all of our kernels patched, which involved a lot of reboots. So we're sending out these communications to teams, and we said, if you would like to never worry about this again, then you can turn on lifetime management, and we will handle the kernel upgrades for you automatically without you having to relearn how to work all this tooling. And this drove a lot of self-service adoption, which was great. But then it turned out that we weren't very well equipped to handle all of this adoption. So there's 3 parts that we weren't very good at. The first part was turning it on. So somebody would come in and they say, I want to enable lifespan management. And we'd say, great, here are our docs, we'll link them to you, and give them this wall of text, just like encyclopedia of lifespan management and all of our design decisions, which was not great. The next part that we weren't great at was defining who does what. So someone would come in and say, what happens during termination? What parts do I need to handle? What parts will you handle? And depending on who they got, they might get a very different answer. Someone might just ramble about all of the things that lifespan management, or that happens during termination, all of our services and the different varieties. And we didn't really have a consistent answer, and it ended up being confusing. And then at the end of this whole situation, the person who's asking the question would say, what part of this is actually relevant to me? Like, you just explained everything about termination, but what do I need to do to make sure that I'm doing it safely? And we'd say, great question. We don't have a doc for that. And then the third part that we weren't very good at was false alarms. So I was actually really surprised how quickly people knew about the lifespan manager and how quickly people were to assume that it was the thing that broke their stuff. So we would have a ton of people coming in and say, hey, something's funny, did lifespan manager just terminate one of my hosts? And we'd say, oh yeah, sure, let me check, I'll check that for you. And we'd check our logs, we'd check some AWS API calls, we'd check our metrics, and 5 minutes later, because we didn't have this, we were not doing very well here, we'd come back and say, nope, lifespan manager did not cause this problem. And then their next question would be, okay, what did break it? Like I wanted to know that, but what they really wanted to know was what they could do next, how they could fix it. So here's how we changed to address these problems. The first part about turning it on, we went from this like encyclopedia of documentation, this really wall of text, to a flowchart that people could follow to say, here's like the explicit decision tree you need to follow to turn this on safely and make it a lot easier. And we had some sort of escape patches there where if you're in some very weird scenario, just come talk to us and we'll figure it out. But that helped like the 80% case to go through happily without having to talk to us, with both us and them feeling more confident about turning this thing on. The next part was about who does what. So we, again, improved our docs here and really made an explicit timeline of this is what happens during termination. And for the most part, people would come here and say, okay, great, it's doing all the things that I was worried about. And then in the sort of, again, in the rare case that somebody needed to do something custom, they knew what knobs they had to turn. So it was, again, like improving our documentation so it was more explicit what the contract does between us and the customer teams. The last part was the false alarms. So we made a short link where you could go why dead and then put your instance ID, and that pulled from all these different sources. And in addition to saying, this definitely wasn't lifespan manager, it would also tell you what did terminate that instance. If it was, an AWS health check that failed or somebody else on your team that you hadn't asked first that went ahead and terminated that instance. And this was useful both for us to be able to answer them more quickly, and then when we started sharing this link, people could, again, self-service to figure out what was wrong with their instances. So what we learned from this was to make it easy to adopt safely. We were having very inconsistent options, and our flowcharts, while they feel kind of janky to throw a flowchart at something, it made it much easier to have a consistent answer to a lot of these questions. We explicitly stated the contract of who was going to do what during termination, so there was less confusion about what was going to happen when and who needed to shut down the services or processes and when things were going to come out of routing and that kind of thing. And we made it easy to rule out the chaos. That turned out to be really important as people continued to assume that chaos was causing their problems. The last discovery we had was about JIRA tickets. So it was about filing too many of them. The lifespan manager would sometimes break, right? It would encounter some problem. It didn't feel comfortable pausing or didn't feel comfortable continuing with termination. But we were a small team, and we were managing this for the fleet for other teams, and we decided that we should farm these tickets out, right? We don't have full context on these systems. We should give them to the people that do have more context. So as an engineer, we automate it, right? We take the metric and create a ticket and assign it to the right person. This seemed awesome at first. Then the tickets started piling up, and we filed a lot of tickets. Turns out it's a lot easier to file tickets than it is to close them. And what we realized is that people either were getting really frustrated with the amount of tickets that we were filing, the people that were actually trying to do them all and do their due diligence on their infrastructure, trusting us to be reasonable about filing tickets, were getting really frustrated. And the people and other teams were just completely ignoring them as something like, I don't know what this is. It's kind of outside my expertise. I'm just gonna, it must not be meaningful. So what we learned from that was to automate as much as possible. It turned out a lot of the tickets we were filing had to do with that sort of 1% flakiness in our termination or bootstrap cycle, which wasn't a problem when we were terminating pretty infrequently, but when we 10x'd our number of terminations, that 1% case happened all the time, and things were getting stuck all the time. So what we did was to automate retries into that. So if it failed to bootstrap a host, we would retry and only file it if we were sure that a human needed to be involved. Another thing we did was sort of to build empathy with our users was to file the tickets against ourselves first before we really farmed it out to them to make sure that these tickets did require that domain-specific knowledge. They couldn't be automated away, and that the ticket was actually something they needed to do. And then we started monitoring the quantity and reliability of tickets. And there's still some work here. I think we eroded a lot of trust about these tickets. So now when someone sees, oh, I've got a stuck ASG, they're like, I have ignored these for months, and it's hard to get that trust back of, no, this is actually meaningful again, we fixed it. So the last part of this story is calling it done. So the last mile of our journey here, where you can see we again had this pretty steep uptick, and this was intentional. What we realized was that we could continue allowing this self-service adoption to trickle out to more people, but we didn't really have a finish line. We hadn't defined a finish line, and we really didn't have a way to get to that finish line. So what we did was we sat down and defined some scenarios that we could pursue and scope out and what that meant. And what we ended up with was we were going to try to enable it for all stateless host types and not try to tackle the stateful ones. And we made an explicit decision. We kind of evaluated we could either continue letting this trickle out, or we could double down on it and invest in it and get it the rest of the way. And we decided that was worth it because it was easier to reason about our infrastructure if all of the stateless host types had lifespan management enabled. And so we switched from this sort of self-service model to a more white glove model where we would go and consult with teams and flip it on and walk them through the process. And that's where we got that steep uptick of adoption there was more like the white glove adoption. All right, so to sort of summarize, old instances are bad, full stop. It's hard to terminate gently, and I think another thing there too is that reducing toil makes chaos a lot easier to sell. We found that teams were much more willing to adopt this tool if they knew that it was going to reduce their toil. They wouldn't have to go in and replace instances. They could, it would reduce the number of things they had to do, and it was easier to convince them that that was what they wanted. The things that we learned were to require explicit evidence for health. So if we were to do this system again, or if anybody else wanted to do this system, I would recommend that, to track feature usage and to expose chaos info everywhere. And this is something we're still working on too, is to really put that info where the customer teams live. We initially had these one-off dashboards and where we knew where to find it, but it wasn't necessarily in their normal workflow, and it was kind of Greek to them. So we're putting it more into the tools that they're using already. So for a takeaway, I would ask if you have looked at your instance age graph lately. If you haven't, maybe consider it. And for your next infra automation project, you can ask, will it inject chaos? And if not, could you add some? It's good to know ahead of time, and it's also worth trying to think about whether you could add some. And even if it's gentle chaos, our gentle chaos taught us a lot. Great, thank you so much.